Hello friends, in today's question, a large open tank has two holes in the wall. One is square hole on the side L at a depth of side L at a depth y from the top, and other is a circular hole of radius r at the depth 4y from the top. When the tank is completely filled with water, the quantities of water flowing out per second from both the holes are same. Then r is equal to. So we are given a open tank which is having two holes in the wall. So let us draw an open tank. So something like this, and on the top there is a square hole. So let us put this is a square hole, and from the if the level of the water is this, so this square hole is at a depth of y, and there is a circular hole, let us put something like this, which is at a depth of 4y from the top. So this is given as 4y. The length of this square is given as L, and radius of this hole is given as R. And it is said that the water flowing per second from the square hole as well as the circular hole is same. So we have to find out the value of R in terms of L basically. So here we are going to use the Torricelli's law, which states that the velocity flowing through the water through a velocity at a depth h is given by v, and that is equal to square root of 2gh. Here h is the height of the hole, which can be square in the shape as well as circular in the shape. Okay. So we are going to use Torricelli's theorem, Torricelli's law. And it states that the velocity v of the fluid of the liquid exiting a hole at a depth h from the surface of the water, surface of the liquid rather, is given as v is equal to square root of 2gh. So this is the basic Torricelli's law, and we are going to use the Torricelli's law first for the square hole and then with the circular hole. And it is said that the quantities per second is same, and which will giving us the final relationship between the R and the L. So let us start for the you can say square hole, and then we go to the circular hole. So we can say flow rate from each hole. So let us do it for the square hole. For square hole, the area of the square hole, let us suppose that is given as a square, that will be equal to length square, and if v is the velocity, or rather we can say v square is the velocity of the liquid passing through the square hole, then v square will be equal to 2gy. Velocity of water flowing through square hole, let us suppose that is given as v square, that will be equal to square root of 2gy. And we can find out now the volume flow rate or water flowing per second. So we can say therefore volume flow rate, let us suppose, is given as q square. This will be equal to velocity of the water through the square hole multiplied by the area of the square hole. So therefore we get q square is equal to square root of 2gy and multiply by L square. So this is our question number 1. Similarly, we are going to solve it for your circular hole. So we can say for circular hole, area of circular hole, area of circular hole, let us call it as a circle, and that will be equal to pi r square, and velocity of the water flowing through the circular hole velocity of water flowing through circular hole, let us call it as v circle, and that will be equal to square root of 2g multiplied by 4y. Therefore the flow rate volume flow rate let us suppose it is given as q circle is equal to v circle multiplied by a circle. So we get q circle will be equal to pi r square and square root of 2gy, and taking 2 as common, so this will be 2 out of the square root, not common. And it is given that volume flow rate of circle and volume flow rate of square is equal. Volume flow rate for square is equal to volume flow rate for circle, or we can circular hole, square hole and circular hole. So this is given to us. So we can say our q square is equal to q circle. So let us substitute the value. Our q square was square root of 2gy into L square. So we write it as square root of 2gy into L square is equal to q circle. This is equation number 2. So we can say from equation 1 and 2, and this we get pi r square square root of 2gy multiplied by 2, and this cancels out completely. So we are left with only that r square is equal to L square upon 2 pi. Therefore, we get R is equal to L upon square root of 2 pi. So this is the value of the R. So if we check the options available to us, you can see the option number A is the correct one. So you can say that option A is correct. So this completes the question. Thank you.